The variance of a random variable x can be found by, but if x and y are two random variables, the variance of x has to be found by. The main difference is that instead of using the probability of x to compute the expected values, we need to use the probability of x. Well, let's see how that works. So here we have a joint distribution. Let's find the variance of x. So we do need the probability that x is 1, 2, or 3, and we can get these from the marginal distribution. The probability x equals 1 is the sum over all possible y values that x is 1 and y is whatever it is. And that will be. Likewise, the probability x equals 2 and x equals 3 will be. And now we can find the expected value. That's the sum of the products of the payoffs and the probabilities, which will be. And the expected value of x squared will be the sum of the payoffs and the probabilities, which will be. And so our variance will be. We might regard the variance of x as the total variance of the random variable. This corresponds to the lack of any knowledge about the value of y. But what if we knew something about y? To incorporate that knowledge, we'd want to compute a conditional variance. If we knew something about y, we could find the probability of x given y. But remember, conditional probabilities are probabilities. To emphasize the fact that this is just a probability, we'll write it temporarily with the condition grayed out. And since we have probabilities, we can find the expected value and the expected value of x squared. Consequently, we can find the conditional variance. Or can we? Remember, the variance is defined as the expected value of the squared deviation from the mean e of x, and so variance is. But if we're finding a conditional variance, we should use the corresponding conditional probabilities and conditional expectations. Now, expected value is still linear, so this expected value can be expanded too, and we can break apart each bit. And here, note that the expected value of an expected value is just the expected value. And so this simplifies too. So our computing formula is still valid. So let's go back to our joint distribution and let's find the variance of x given that we know y is equal to 1. So first we have our computing formula, and now we want to find these conditional expectations. So that expected value, well, that'll be the payoffs, 1, 2, or 3, times the probability that x equals 1, 2, or 3, given that we know that y is 1. Replacing those conditional probabilities using Bayes' theorem, we get. And so our expected value will be. Meanwhile, the expected value of x squared, given that we know that y is equal to 1, will be. And so we find our variance.